So what we have is we've got a cyclic quadrilateral, and we're told that two opposite sides are equal. So given this, we've been asked to show that the other two sides are parallel. So here we got a nice circle, and this is one side. And let's copy that because these two sides are equal. So I'm just going to label this side A, this vertex B, C, and D. I'm going to go ahead and connect up A and B, and D and C, D and C. So we're told that AD and BC are equal. What does this mean? Well, this also means that the arc AD and the arc AD and the arc BC must be equal. Arc BC. Because these two lines are equal, the two arcs that they subtend must also be equal. So what does that mean for us? Well, I'm going to do something. I'm going to go ahead and connect up B and D. Now I'd like to look at these two. I'd like to look at two of these angles. I'd like to look at angle ABD and angle BDC. What do we know about these angles? Well, we have Handy's little circle theorem. Theorem 2. If we draw a circle, and we draw a diagram like this, this angle and this angle subtend the same arc. This means that A must equal B. Why is this relevant? Well, because arc AD is equal to arc BC, these two angles also subtend the same arc. So what does that mean? That means they must be equal. Angle ABD equals angle BDC. So why is this relevant? Well, we've got another little proof of here. Consider this diagram. These two lines are parallel. This is a line. Now, we know that this angle and this angle are alternate angles and therefore are equal and add up to these two angles must be equal. Why is this important? Well, we've actually got the same situation here. We have two lines that we're trying to show are parallel. And we notice these two angles with the same transversing line are equal. So what does that mean? Well, these two lines must be parallel. AD is parallel with BC. We know this because these two angles are equal, and we have this transversing line, the same situation that we have up here. So these two lines must be equal. Why is this important? Well, if these two lines are parallel, then and equal, then AB must also be parallel with CD. Otherwise, they wouldn't form a quadrilateral within a circle like this. So we've shown that two opposite sides of a cyclic quadrilateral equal well. Our cyclic quadrilateral is A, B, C, D. And our two opposite sides, A, D, and B, C, are equal. The other two sides, A, B, and C, D, have been shown to be parallel. So we're done. We've shown that, according to circle theorem 2 and alternate angles, two opposite sides of a cyclic quadrilateral are equal. That this means the other two sides must be parallel. We're done.